ENG and we will be presenting our brake system capstone project. My name is Ahmed and my group members are Ayad, Mohammed, Mahjoub, Ryan and Yusuf. We will begin by explaining the objective of our project. The key objective of this project is to design a braking system for the Lassonde Motorsports Club FSAE vehicle. There are three main requirements to the brake system. First and foremost, it must be safe. Secondly, it needs to perform competitively. And finally, it must adhere to the requirements of the FSAE rulebook. Now we'll go through some of the requirements for our project. In this slide you can see our requirements table. Thus far the requirements in green have been verified and the requirements in yellow are still pending. This is a continuation of our requirements table and the requirement in red has been eliminated as it was deemed to be unfeasible. As we can see at this phase in the project most requirements have been verified. Now I will showcase some of the progress made thus far throughout the Capstone project. We have designed the brake system, verified our requirements through simulations, and designed a test rig to verify the requirements with further confidence.
Team G2 for the Lassonde 2020 Capstone project. Our project is called the braking system for the FSAE car, and our main stakeholder is the Lassonde Motorsports team. Through the life cycle of this project, we've gone through various challenges, starting with a communication challenge due to the global pandemic. Our team has never actually physically met in person, but we've been able to actually get through different challenges, able to cross various hurdles, and now we're at the final stage of the project. I'm going to take you through a brief life cycle of the entire project. In the initial stage of the project, we had to define a problem, state what our stakeholder wanted and what we were going to do for them. Following that, we had a critical design review. At this point, we had come up with the entire budget. We had selected materials for each and every component of the hydraulic system. We had started to calculate our maximum pressures and our maximum allowable tolerances for each part. And at this point, we're ready to begin testing. To put in perspective, factory acceptance testing is performed at our facilities, so here the design work done. All site acceptance testing is going to be performed after assembly is complete. At this point, when site acceptance testing correlates with factory acceptance testing, all our test parameters are passed, we can continue to deploy our system into the FSAE vehicle and we'll give ourselves a pat on the back and drop it. Thank you folks, thank you so much for watching this video.
Hi, I'm Naveed.
Peter.
John.
I'm Alex and we're Team H.
And over the past year, we've been developing a drivetrain system for a Formula SAE vehicle in partnership with Lassonde Motorsports, York's home racing and vehicle design team.
The drivetrain is the subsystem of the vehicle delivering power from the engine to the wheels, essentially making it move.
The drivetrain is comprised of several components working in harmony, custom made for Lassonde Motorsports' current generation vehicle, which aims to hit the track as soon as competitions open back up again.
Among our deliverables, we define manufacturing methodology, assembly instructions, and testing procedures.
We have spent countless hours over the past 8 months working from the ground up, starting with how LM wants the vehicle to perform, and ironing out the small details with other teams.
The result is a drivetrain system made from mostly custom components, with the addition of a select few parts bought online and picked off the shelf.
Going forward, LM will integrate the system into their vehicle, moving them one step closer to being competition ready.
Hello, we are Team I, the Whiplash Reduction System team. What we will be covering today is the journey we took from start to finish of this project. Things we researched, how we analyzed the concept, the prototype build, testing, results, and improvements. Whiplash is the most common injury in all car accidents, and can even occur from hard braking. We don't train our necks like Formula 1 drivers, and it would be highly uncomfortable to take motorsport level precautions in everyday vehicles. Spinal issues and recoveries are extremely expensive and painful to go through. Most vehicles have protection built on the outside of the car with reinforcement bodies and crumple zones. However, there are very little mechanisms within the car to reduce the most common injury of all. The scope of this project focuses on the research results we came across, such as the driver being at the highest risk, tall individuals being at the highest risk, and rear impact being the most common to cause injury. Further operational constraints were based around the 8-month course length, $1,000 budget, and general COVID restrictions.